So for the first video problem we did in class, we looked at a smart car crashing into the wall, and we assumed that it compressed 1 meter. We converted. Remember, we were told it goes from 70 miles an hour to 0 and it compresses and crashes, and we wanted to know the acceleration of the car and the time it takes to stop. And what I wanted to do with this is basically go through our process of solving this. Now, again, I'm already seeing people skipping steps, and what that means is I'm already seeing people who are going to get points off on the test because I know it seems like you really know this stuff because it's straightforward based on the fact that you guys are really, really, really smart. But please have some patience. Go through the recipe a couple times before you try to wing it on your own. Just use the safety net to start with and try that first before you completely wing your own way of doing this. So I'm going to follow it for sure. And what that means is in this case, I've got our car starting with an initial speed of 31.2 meters per second, and it comes to rest. So what that means is that its final velocity is 0. Now this compressed 1 meter, this is something you're going to need to sort of think about on exams, and sometimes we sort of say it that way. So when we say a car is compressed over 1 meter, that means it moves forward 1 meter. So we'll give it a starting position of 0 and say that its final position is 1. Now, that is step 1 done of our recipe, and if you remember, this is the recipe we have. So we have labeled each letter in the problem. Now let's go ahead and write the list of unknown and known variables. So x naught x, v naught v, t a. So x naught is 0, x is 1, v naught is 31.2, the final velocity is 0. You know what, just for the sake of completeness, I'm going to put units on these. I don't know the time, and I don't know the acceleration. Well, that's annoying because those are the two things we actually want to find. So looks like we don't get out of this one easily enough. So what's the next step? Because we just finished step 2, we want to draw a labeled picture. And so continuing with the labeled picture, let's just draw a smart car like this. So this is my version of a smart car. And what's going to happen is it's going to crumple. And what I'm going to say is that it kind of crumples over 1 meter. That's a really bad drawing, I know. And so we go from, I should actually say, I should draw it like this. Here's 0 to 1 meter. And what I'm going to say is that we start off with a speed of 31.2 with a final speed of 0. And I'm just going to leave it at that. I don't think we really know anything else. And then I'll just draw the crumpled car right here. It's a bad drawing, but it's the best I can do. And I know some of you really have much better skills than I. And then the third thing I'm going to do is I'm going to go ahead and plug in numbers into every single equation, regardless of whether I think it's going to be helpful or not. So v equals at plus v naught. Great. So let's plug in our numbers. We have here that 0 equals at plus 31.2. Oh, that's really sad because I love it when I can use the easy equation. So that sucks. So let's use the second equation now. We're going to have v squared equals v naught squared plus 2 times the acceleration times x minus x naught. Let's go ahead and plug in our numbers. So if we do that, we're going to get 0 squared. Sorry, it's going a little bit slow here. Equals 31.2 squared plus 2 times the acceleration times 1 minus 0. So I'm going to actually just go ahead and get the number here because my computer is being a little bit weird. And so when I actually calculate the number, the answer I get for the acceleration is, I'm actually going to end up getting negative 486 meters per second squared. And so what that means is for part C, they're going to die. This is not going to be a survivable crash. Now what we can do is we can actually go back and get the time if we want to. So for step 5, I will now go back and solve for what I can solve for. Well, actually, that's what I did here. I solved. Now, for step 6, I'm going to go back and solve for what I can solve for. So what I'm going to do is, because my computer is being a little bit slow, I'll just tell you, plug in the acceleration into this equation here and solve. And when you do that, the answer you'll end up getting is about 0.064 seconds. About 64 milliseconds, which actually is a typical crash time. So it's kind of cool that we can watch a YouTube video and get a decent answer on a number like this. So that's the outline of the solution to this problem. And I'll actually post this up on Schoology in the next couple minutes.